Okay, can you guys hear me?
Yes.
Yes.
Okay, so today, yesterday I had class with the JC1 Truth. Okay, so today also, we will actually look at the revision part first. Okay, I will go through some of the reaction that we actually have done previously. So once we actually done this reaction, we will actually move on to the next part of this session at 5 o'clock today. So today we will have a session at 5 o'clock. Now, I'll start now. Okay. Now, carbonyl compounds. Okay, carbonyl compounds, we have aldehyde and ketone. Okay, carbonyl compounds is anything that has C double bond O. So aldehyde, okay, the structure of aldehyde is C double bond O and H, and then it can be R over there. And ketone will be R1, C double bond O, and then R2. Okay, that is going to be the difference between aldehyde and ketone. Now, I have actually done the preparation of aldehyde. How do we change aldehyde? Okay, how do we actually change primary alcohol to aldehyde? Because we have learned that primary alcohol, when they deoxidize, okay, it will give you aldehyde. And then after you further oxidize, it will change into carboxylic acid. So it's very crucial to adjust the way that we form aldehyde, because we do not want your primary alcohol to be oxidized directly to carboxylic acid. So therefore, we need to make some adjustment. One of the adjustment is you do not see some kind of a condenser over here, a vertical condenser, because you do not need to actually heat them under reflux. Okay, do not heat under reflux, because if you heat them under reflux, you are going to actually change this primary alcohol to become carboxylic acid. So we don't want that. So instead of heating under reflux, we are going to heat them gently, and we are going to add the oxidizing agent drop by drop. And as we are adding the oxidizing agent, as the alcohol change into aldehyde, the primary alcohol change into aldehyde, we are going to actually distill them immediately. Okay, so you are going to get the ethanol formed over there, the aldehyde formed over there. But we need to consider what are the suitable oxidizing agents that will be used for this reaction. So maybe I'll actually call some of you. Okay, maybe Frey, can you tell me one of the oxidizing agent that we can use in lab?
Potassium dichromate.
Okay, potassium dichromate, K2Cr2O7, but you must make sure that they are acidified. Okay. Yeah. How about another one, Jody?
Potassium manganate.
Potassium manganate. Okay. Now, do remember it's going to be acidified also, but if you want to write the full name, what is the oxidation number for potassium dichromate? 7 or 6? It's going to be 6. Okay. I want you to remember this. Potassium manganate is going to be 7. Okay. Take note of this. Okay. Now, what is the observation? Okay. Lavi, for the first one, what will be the observation if there is a positive observation?
Orange to green.
The first one, yes, correct. You're correct. Sorry, Lavi. So orange to become green. And then Nicole, the second one?
Purple to colorless.
Okay, good. Purple to colorless. Now, I will just move on to the preparation of ketone. Preparation of ketone, you just do like normal, because secondary alcohol, they change into ketone, then the ketone will not be further oxidized. So no problem with that. So you can either heat them gently, you can heat them under reflux, doesn't matter. So no issues. So the preparation part is done. Okay, the preparation part is done. Therefore, we'll go for the first reaction of aldehyde and ketone. The first reaction of aldehyde and ketone, okay, I have written over here, okay, primary alcohol, okay, they can actually change, okay, from aldehyde to form aldehyde and further oxidize to give you carboxylic acid. The same thing, if you have secondary alcohol, okay, they will be changed into ketone. Okay, they will be changed into ketone. There is no further oxidation. So therefore, okay, we have learned also in the past, okay, carboxylic acid, okay, will actually undergo a reduction reaction. Okay, and that reaction, I want you to recall again. Carboxylic acid, how do you change carboxylic acid to become primary alcohol? Justin, how do you change carboxylic acid to become primary alcohol? Reduction. Okay, Justin have written over there reduction. So the reduction, okay, I want Richard. Richard, can you tell me what is going to be the suitable reducing agent that will be used for carboxylic acid change into primary alcohol? We have learned about this. Richard? Okay, we'll call someone else. Okay, Richard is not responding. Alvin? Alvin? How do you
Hello?
change carboxylic acid? Okay, how do you change carboxylic acid to become primary alcohol?
Did you ask me, sir?
Alvin.
What's the question, sir?
What is the, how do you change carboxylic acid to become primary alcohol? There is a reduction. Justin already mentioned it's going to be reduction. So what is the
Okay.
reducing agent that we use? Yeah.
Wait.
Let's not waste time, yeah? So LiAl
H4.
H4, okay? And in dry ether, okay, in dry ether. So here, okay, you need to make sure that you are using LiAl H4 in dry ether. And do remember, this is going to be a strong reducing agent, okay? But now, okay, I'm going to introduce another reducing agent because now I want to actually go back, okay, rather than actually having oxidation, I'm going to actually change aldehyde to primary alcohol, ketone to secondary alcohol. I'm going to have reduction over there. But for reduction, okay, for carboxylic acid to change into primary alcohol, you need to have a strong reducing agent. But here, you just need a decent reducing agent, a mild reducing agent. But if you want to use a strong one, also doesn't matter. So therefore, you can still use LiAlH4 in there. Will be another new reducing agent that will be included over there. You can actually use NaBH4, okay, NaBH4, and it must be in alkaline condition and it must be warm, okay, it must be warm. So in dry ether, it's going to be room temperature. So I'll put RT. Okay. So take note, lithium, aluminum, tetrahydrido, okay, eliminate. Okay, it will change into, okay, they are very good reducing agent. Okay, so it can help to change carboxylic acid to primary alcohol. But when it comes to carboxylic acid changing to primary alcohol, okay, you cannot use NaBH4 alkaline and warm because it's not strong enough. Okay. Now I want you to look at the example that is given over here. There are two examples. One is going to be using aldehyde, another one is going to be by using ketone. So there is a reaction by using, let's say they put the H over there, and then they actually mentioned that it's going to be reduced. Okay, it's going to be reduced. So if I just put it over there, okay, plus. So what's going to happen is this aldehyde is going to change into alcohol. So I'm going to actually put CH3, and I'm going to actually put the CH2, HH, and then you have OH. It will change into this. So what is happening over there? I'm just going to get additional 2 hydrogen. So I just put 2 hydrogen over there. And then the same thing here, what is going to happen is 1 hydrogen is added to the oxygen and then another hydrogen is added there. So you are going to get something like this. Okay, so this is going to be again 2 hydrogens. So this is going to be, take note, this is aldehyde. So it's going to be primary alcohol. And this is going to be ketone. So this is going to be secondary alcohol. Do you have any question until now? Janice, do you have question?
No, sir.
Okay. Now, so when we actually, the next part, okay, is going to be the mechanism of the reaction of aldehyde and ketone. Okay, so what we are going to look at it is going to be, the mechanism is going to be nucleophilic addition. So I would like you to actually look at the recap part over there. Okay, the recap part is just to tell us that what are the things that we have learned until now. So the reactions that we have learned until now is going to be free radical substitution. This free radical substitution we learn for what? Victoria? Free radical substitution we learn for?
Yes, sir. With for the chlorine.
Alkane, alkene, what?
Oh, alkane, yeah.
Yeah, alkane. Okay, how about electrophilic addition, Nicole?
For the halogeno alkene.
No, electrophilic addition is going to be alkene. So the first one is going to be single bond carbon, and then this one is going to be double bond carbon. That's going to be electrophilic addition. Okay, is that clear, Nicole?
Yes, sir.
Okay, the next part, okay, let's actually, Derek, okay, how about nucleophilic substitution? There are two compounds that will actually undergo nucleophilic substitution. Derek?
Yes, sir. Can you repeat the question? You got cut off.
There are two compounds that will actually undergo nucleophilic substitution. We have learned nucleophilic substitution before. So what are the two compounds?
Alcohol and halogenoalkane.
Okay, good. Okay, alcohol and halogenoalkanes. Okay, we have learned about this. Okay, now we are going to learn about the fourth reaction, which is going to be the nucleophilic addition. So I want you to remember all this. This is nucleophilic addition. Okay, so nucleophilic addition, okay, aldehyde and ketone. Okay, one of the reaction that they actually mentioned in the textbook over here is the reaction with HCN. Okay, HCN, and take note, HCN, they can actually form a nucleophile, which is going to be H plus and then CN dot minus. Okay, this is the nucleophile. The definition of nucleophile. Okay, what is the definition of nucleophile? Let's actually get Jody to give us the definition. Jody, any
Definition
species that
of
has
nucleophile, sir.
yes. You can see over here. I already mentioned that this is. Rather than that, you can say any species that has a lone pair of electron.
Oh, okay.
Okay, so they are attracted towards positive, so they are negatively charged. Okay, but when you give the definition, I want you to give the definition in this form. So it's going to be any species that has a lone pair of electron. So that's going to be a nucleophile. Okay, so here they mentioned in the textbook that when you react, they are going to give you a product which is going to be 2-hydroxynitriles. Okay, so what is 2-hydroxynitriles? Okay, it's a general term to show that the nitrile, this is nitrile, and this is going to be carbon. This is carbon number 1, carbon number 2. So this is OH. So this one is going to be the hydroxy. The number 2 is because of the 2. The hydroxy is going to be at number 2, carbon number 2. So this one definitely will give us 2-hydroxynitriles, okay, nitriles. So if you look at the textbook, they also mentioned that HCN is going to be prepared in situ. Okay, what is the meaning of in situ? Okay, let's actually get someone to tell us what is going to be. Shane. Okay, what is the meaning of in situ? Shane? Shane?
Yes, sir.
What is the meaning of in situ?
In the same reaction vessel.
Yes, good. Okay, in the same reaction vessel. So in situ is prepared in the same reaction vessel. So what is prepared in the same reaction vessel as aldehyde and ketone? They are going to actually add NaCN with dilute H2SO4. They are going to give you NaHSO4 and you are going to get ACN. This ACN is going to actually react with the aldehyde and ketone. So that's going to be the reaction. So before we go into that reaction, okay, they have mentioned that nitriles, this is nitriles. Okay, nitriles can actually undergo two reactions. Okay, one of the reaction we have learned when we learned about carboxylic acid. Okay, the nitriles, when you reflux with dilute HCl, okay, you are going to change the nitrile into carboxylic acid. So, and then ammonium ion. So this one, I want you to look at my PowerPoint slide on preparation of carboxylic acid. Okay, you prepare carboxylic acid by using nitrile. You reduce the nitrile using dilute HCl. you are going to get carboxylic acid. So it is one of the very important reaction over here. And then, okay, the new one that they actually mentioned in this chapter is the nitriles, okay, they can be reduced. Okay, they can be reduced to become what? They can be reduced to give you amine. Okay, amine is any compound that has R and H2. So you are going to change this nitrile into CH2 and H2. So you need how many total hydrogen? One hydrogen will come here, one hydrogen will come here, another hydrogen will come here, another hydrogen will come here. So you need total of 4. Okay, and what is the reagent that we will use for this reaction? The reagent is going to be sodium and ethanol. You need to heat them. So this is going to be slightly different, okay, because you see here, this is reducing agent. Okay, just now we learned about reducing agent also. Okay, we learned about LiAlH4 is a very good reducing agent in dry ether. And then we have learned about NaBH4 is a very mild reducing agent. So it must be in alkaline condition and it must be warm. But we also have another reducing reagent, which is going to be sodium, okay, and in ethanol, okay, sodium in ethanol, and it must be heated. But we only use this sodium in ethanol and heated only to convert nitriles, okay, to become amine. Is that clear?
Yes.
Yeah. Now, I will actually show you the reaction. Okay, I'll just show you here. I have prepared something over here. Now, if I want to actually write down the reaction, like for example, the mechanism of the reaction using the curly arrow diagram, okay, you need to actually know how to use a curly arrow diagram. We have learned this using curly arrow diagram many times already. So the curly arrow is to show the movement of the electrons, okay, the movement of electrons. So the electron is going to move, okay, so have a look over there. And then I mentioned also just now, if you are using ACN, it is done in situ, okay, in situ with what? Sodium NaCN. Okay, it is done with NaCN plus H2SO4. It will give you NaHSO4 plus ACN. Now, this ACN, okay, take note, they can change into H plus and CN dot dot. Sorry, better to actually write it down like that. Dot dot minus. Okay, they will change into like this. Okay, where this is going to be a nucleophile. So, and since it's going to be a nucleophilic addition, okay, nucleophilic addition, I need to actually show that there is a presence of CN dot dot minus over there. Okay, so if I want to actually show the reaction, first step, what I need to mention over here is, okay, the first step is going to be, if I rewrite again, okay, actually no need to rewrite. Okay, what I can do is, okay, if I actually do a lazy work over here, okay, when you have this, okay, when you have this, and what is going to happen is this oxygen is going to be more electronegative, okay, than carbon, so it will give you a delta negative over here, and this is going to be a delta positive. And then the CN, okay, the CN from where, if you're wondering, the CN from ACN, okay, they will actually use this opportunity to attack the delta positive, the carbon, okay. And what they will actually do, they will actually form, okay, this molecule, single bond, the double bond will be broken. Why broken? The electron went directly to the oxygen. And then you have CH3, and then you have CH2, CH3, and then the CN went in, so just put CN over there. This is going to be the first step. Now, the second step that is going to happen over here is, okay, you have this molecule. So if I actually do the same thing again, okay, I have this molecule, and I put it here. Okay, I have this molecule, and then this molecule, okay, is going to actually react, okay, with HCN, okay, HCN. Now, I will write HCN in this form. Because of the presence of negative charge, okay, the electrons will all go to the Cn. Okay, will go to the Cn, making this as partial positive and partial negative. So what's going to happen next is this one, the partial positive, and then electron, this electron over here, they will actually go and attack this partial positive, making it this one to be broken. So you are going to get, okay, something like this. If I do it again. Okay, I'm going to actually get something like this. The H will come over here. Okay, I hope you understand. Basically, I'm just trying to say that the H will come here. Okay, if I just, never mind, I can actually write it down. H3C, Cn, CH2, CH3. Okay, the H will come over there. So that's going to happen. And then this one, if I want to delete, it's okay, fine. Okay, and then left with this Cn dot dot minus. Okay, so because of the Cn over here, the Cn will cancel. So if you look at overall, the overall reaction is going to be, you are going to get any kind of aldehyde or ketone. Okay, let's say I put ketone. When I react with HCN, what's going to happen is I am going to get R1 COH. Okay, this H will go beside the O, and then you have R2, and then the Cn will come. And take note, okay, this is carbon number 1, this is carbon number 2. So this molecule is actually known as 2-hydroxy nitrile. So you can name accordingly. Do you have any question up to here?
No.
Okay, actually lesson is done, okay, but I'm just waiting for question. If you have question, just ask me, we still have time.
Sir, so that become 2-hydroxy pentanitrile.
For this one, is it? Okay, for
Yeah.
this one is going to be, if I put the, if I complete, this one is CH3. So this one is going to be, if I look at it, the longest carbon chain. Do remember this one is always carbon number 1. So if I look at the longest carbon chain, it's going to be, this one is the longest carbon chain. So how many carbon? 1, 2, 3, 4. If I follow here, 1, 2, 3. If I follow from here, definitely shouldn't be 1, 2, 3, 4, cannot. So it means there's 4. Okay, so this one is butane nitrile. Okay, butane nitrile. And then at position number 2, there's hydroxy. So this is 2-hydroxy. And do remember at position 2, there's a methyl group. So 2-methyl. Can you understand? This is how to name.
Okay.
So naming part, I don't want you to focus so much now. Okay, do remember the compound will be always called hydroxynitrile. Okay, hydroxynitrile, 2-hydroxynitrile. So the OH is always at position number 2. Other questions? So maybe I'll just call randomly. Frederick, do you have any question? Frederick just asked. Yeah, Frey, do you have any question?
No, no.
Who else? Shane, do you have any question?
No.
Johannes?
No, sir.
Janice, do you have any question?
No, sir.
Okay, so I think no question, but do remember today we have another session at 5. We will enter the new, not the new part, it's a new part, okay, within the same chapter, but it is very important, testing for carbonyl compounds. Okay, so make sure you attend. Today is very important lesson. All right. If there is no
Yes.
question, then I'll stop today's session. Thank you, guys.
Sir,
Guys,
Justin has question.
Okay, guys. Anyway, before I forget, Miss Chandira will actually will upload a quiz. She will activate a quiz. If she didn't activate the quiz, please actually remind her. Okay, then she will activate the quiz. I told her to activate the quiz roughly about 12:05 or something like that. It's a 5-minute quiz. Now, Justin is asking to repeat the second step again. The second step is quite simple, Justin. So basically, it's going to be the first step. Okay, is going to be you are going to get this molecule. Okay, the CN will come in. The second step is, okay, because of the presence of the negative charge over here, okay, it will actually make the HCN, the electrons will actually further be going into there, because not all the HCN will change into the nucleophile. So what's going to happen? Some of it will be still in HCN form. So this HCN, this intermediate or the product, the negative product, is going to actually push the electron towards the HCN, further making it to form more nucleophile. It means this one is actually going to make this one to be formed more. So what's going to happen is this H, delta H, okay, delta positive, okay, the electron from here will actually go towards the delta positive because it's a nucleophile, okay, they like positive. So what's going to happen? There is going to be movement of the electron towards this H. So O and H, this H will join. So you will get the OH there. So it means I'm just putting the H over here. Is that clear, Justin? All right. All right. So if there is no question, okay, if you have question later also, you can always actually ask me later, okay. I'll see you again at 5, but check with Miss Chandira that about regarding the quiz, okay. The quiz should be activated. It's a simple quiz. Whatever that we have done over here, I have actually put that in a simple quiz, 5 questions only, okay. See you guys.
Okay, bye, sir. Thank you.
Bye, sir.
Bye,
All right.
sir.
Bye,
All right.
sir.
See you. See you. See you. See you. Bye.